This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Today's discussion delves into a fascinating patent, electronic device that computes health data. It proposes a revolutionary way to gather health information using technology we all carry around.
Indeed. The patent suggests leveraging the sensors already present in many smartphones to perform health assessments, eliminating the need for specialized, often expensive medical devices.
Intriguing. So instead of a dedicated fitness tracker, we could use our phones?
Precisely. The key is combining the capabilities of the camera, ambient light sensor, and proximity sensor in novel ways.
And what kind of health data are we talking about?
A surprisingly wide range, from pulse rate and oxygen saturation to even blood pressure indices.
How does this work? Can you explain the sensor fusion aspect?
The patent proposes using the sensors not in their traditional roles. For example, the proximity sensor, often used for screen lock, could emit light into a user's finger or earlobe.
And the other sensors would then receive the reflected light?
Exactly. The camera, ambient light sensor, and even the proximity sensor itself can act as receivers. The variations in light absorption provide crucial data.
So it's analyzing how much light is absorbed by the body part?
Yes, and that absorption varies based on blood volume, hydration, and other factors. The combined data from multiple sensors allows for more accurate readings.
That's clever. But how does the device interpret the light absorption data to calculate, say, pulse rate?
The changes in light absorption correlate with the pulsatile nature of blood flow. As blood volume increases and decreases with each heartbeat, the reflected light changes accordingly. Sophisticated algorithms analyze these changes to determine the pulse rate.
And what about other health metrics? How does it differentiate between, for example, oxygen saturation and hydration levels?
Different wavelengths of light are absorbed differently by various components of the blood and tissue. A multi-wavelength proximity sensor, for instance, could provide more nuanced data, allowing the device to distinguish between these factors. The use of infrared light adds another layer of information.
This patent also mentions electrical contacts. What role do they play?
The electrical contacts allow for the measurement of electrical properties of the body. This opens up possibilities for measuring things like electrocardiograms, ECGs, or galvanic skin responses.
So it could potentially measure heart activity directly?
Yes, by placing contacts on appropriate body parts, the device could obtain an ECG. The placement is crucial, and the patent suggests strategic positioning to measure across the chest, for example.
That's quite a leap from a simple proximity sensor. How does the device handle potential misalignments of the user's body part with the sensors?
The patent addresses this. The camera plays a crucial role in detecting misalignment. Even with a camera having a focal length longer than the distance to the body part, the camera can still detect the position and orientation of the body part.
So the camera acts as a guide?
Yes, it provides visual feedback. The device could display a visual indicator showing the ideal position of the user's body part relative to the sensors.
And what if the user isn't perfectly aligned? How does the system compensate?
The system could provide real-time guidance, perhaps using visual cues, audio prompts, or even haptic feedback to help the user adjust their position for optimal data acquisition.
The patent mentions different types of sensors. What are the advantages of using, say, an indium gallium arsenide ambient light sensor over a silicon one?
Indium gallium arsenide sensors can detect a broader spectrum of light, including infrared, which is crucial for certain health measurements. Silicon sensors are more common and cheaper, but their sensitivity is more limited.
And what about the proximity sensor? Why is a multi-wavelength sensor beneficial?
A multi-wavelength sensor, such as one using infrared and visible light, allows for more comprehensive data collection. Different wavelengths penetrate tissue differently, providing more information about the underlying structures.
How would this all be implemented in terms of software and processing?
The patent envisions a processing unit within the phone that receives data from all sensors, runs sophisticated algorithms to interpret the data, and then presents the results to the user. This requires powerful processing capabilities and advanced signal processing techniques.
And what about data privacy and security? This is sensitive health information, after all.
That's a critical consideration. The patent doesn't explicitly address this, but secure data handling and encryption would be essential for any practical implementation.
Let's go back to the types of health data this device could compute. You mentioned quite a few.
Yes, the patent suggests a wide range, including blood pressure indices, hydration levels, body fat content, oxygen saturation, pulse rate, perfusion index, and even ECGs and photoglyphosmograms.
That's a comprehensive list. Is there any particular health metric that this technology is particularly well suited for?
Perhaps pulse rate and oxygen saturation, as these are relatively straightforward to derive from light absorption changes. ECG acquisition requires more precise contact placement and signal processing.
What are the main advantages of this approach compared to existing methods?
The primary advantage is convenience. It leverages existing technology in a novel way, making health monitoring readily accessible without requiring specialized equipment.
And what are some of the limitations?
Accuracy is a key concern. The accuracy of the measurements will depend heavily on the quality of the sensors, the algorithms used, and the user's ability to correctly position your body part. Also, the technology might not be suitable for all individuals or health conditions.
What are the potential future implications of this technology?
This could revolutionize personal health monitoring, making it more accessible and affordable. It could lead to earlier detection of health issues and improved management of chronic conditions.
Could this technology be integrated into other devices beyond smartphones?
Absolutely. The principles could be applied to smartwatches, fitness trackers, or even other wearable devices, expanding the reach and versatility of this technology.
How does this technology compare to existing health monitoring devices like smartwatches and fitness trackers?
Existing devices often rely on specific sensors designed for a particular purpose. This patent proposes a more versatile approach, using readily available sensors in a smartphone to measure a wider range of health parameters.
So it's about leveraging existing hardware rather than designing new specialized hardware?
Precisely. This could significantly reduce the cost and complexity of personal health monitoring.
That was a great discussion. Thank you for sharing your expertise on this innovative approach to personal health monitoring.